Yeah, hello, is that ABC News? Hi there. I wonder if you can put me in touch with someone in the marketing department. Yeah, great, thanks. Yeah, I'll hold.
Round, 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 the earth is round. Smart people found that the earth is round. There's proof abound, don't fool around. The data's sound, the earth is round. Like an apple or a melon, being sailed by brave Magellan. Yet you ask, is this all true? What the hell, what's wrong with you? Like a snowball or a beat, it spins through space, it's really sweet. Your lack of science is quite rife. Goodness gracious, get alive. Round, 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 the earth is round. Smart people.
If there is one man who thinks he's top of the heap when it comes to flat earthers, it's this guy.
My name is Mark Kendall Sargent, and I'm a flat earther.
Hello all and welcome to Flat Earth Friday with me, Simon Dan. Before we start, I just want to thank a couple of people. You may have noticed a nice new intro that was kindly put together by a channel called Luba Babu Music. Massive thanks to him. The link to his channel is in the description. You might have also noticed a new logo in that intro as well. This was made by Wolf Brothers Cinema. A couple of great guys, and they're funny too. You must check out their channel. Thank you very much, guys. So, that was Mark Sargent in the intro clip there, who is probably one of the more famous flat earthers around. He's appeared on national TV and radio here in the UK, and it appears that he is somewhat of an expert when it comes to all things flat earth. Last month, he appeared at the Flat Earth Conference in Canada. Hi, Flat Earth fucker. And today we're going to take a look at his opening statement. The hope is that this will be one of my most comprehensive responses to date. So buckle up.
Some months ago, a German television team contacted me because they had heard about my science challenge and had found a physicist at Georgetown University I could debate. They also wanted to make it as easy on the scientist as possible, so their idea was simple. They would record me on video, reading 5 quick science-based questions, and then send that recording over to Georgetown, and he would respond in kind.
In principle, this is a great idea. My only problem is I'm guessing he will use a load of old pseudo-scientific flat earth claptrap and possibly some fake facts. Let's begin.
This is what I read on camera. 1. Long-distance photography. The mainstream science formula for the curvature of the Earth is 8 inches per mile squared. An easy comparison would be the falling rate of 32 feet per second, so 8 inches per mile per mile. 2 miles is 2 times 2 equals 4 times 8 inches, or 32. 3 miles is 3 times 3 equals 9 times 8, or 72, and so on. At 50 miles, the curvature is 50 times 50 times 8, coming in at over 1,600 feet of curvature. And yet, with HD cameras, we can pull boats back into frame that are well beyond visual range.
So, what does that statement prove? 50 miles is beyond our normal visual range. If you're up high enough, then I've no doubt that you can do that. However, at sea level, it's not possible. I scoured the internet and could not find one example of a boat being zoomed back into view that's 50 miles away, taken from sea level. Not one.
Not only does the new technology clearly show that it's not a mirage, but the same objects can be viewed in infrared.
Infrared cameras detect infrared radiation. This is the band of light in the electromagnetic spectrum that is essentially felt as heat. Boats give off heat, so it's not surprising that it can be seen. It's also important to note that infrared is still a form of light. It still refracts.
and can be targeted ship to ship by beam radar.
Also not surprising, radar transmitters are usually located at the highest point of a ship. And guess what? The radio waves or microwaves can bounce off the Earth's ionosphere, dramatically increasing its range.
Can science explain this? They had no answer.
Okay, bit strange why they wouldn't have, but let's continue.
Number 2, vacuum versus gravity. The force of a vacuum is measured in units of torr, T-O-R-R. Even a low-level vacuum can overcome gravity here on the surface. In building molecule-free chambers for the manufacturing of electronics, a series of massive pumps are needed to create a 99% vacuum. That's -9 torr. And for the remaining 1%, horsepower isn't enough. It can only be achieved by a chemical leaching process. That being said, how is the -10 torr vacuum force of space not ripping off the atmosphere of this world?
This one's a common mistake made frequently by flat earthers. Vacuums don't suck as a rule. If you have a small vacuum here on Earth and you poke a hole in the side of it, then yes, air will rush into the container. Now, that's not because the vacuum is sucking the air in, it's because the higher pressure outside the container is forcing the air into a space where there's no pressure. It's why the astronauts on the ISS could easily plug that hole with their finger. They're fighting pressure of 1 atmosphere inside the spacecraft. The gravitational pull of the Earth keeps the atmosphere clinging to the planet. This means that the atmosphere has a pressure gradient. Think of the ocean. Just below the surface there is very little pressure. However, as we go down deeper, the pressure increases. At 1 kilometre down, the pressure is just over 76,000 torr. This is because of the huge volume of water above. At 500 metres depth, the pressure is just over 38,000 torr, because there is less water above this point than at 1 kilometre. This is demonstrated well by placing 3 holes down the side of a full water bottle. The slightly greater pressure of the water at the bottom, due to all the water on top of it, pushes the water out of the bottom hole at a greater rate than the other 2. Now it's the same with our atmosphere. The atmosphere is also a fluid, like the sea. Here at sea level, the pressure is greatest because of the huge volumes of atmosphere sitting above us. It's about 760 torr. 1 kilometre up, the pressure is 676 torr, 5 kilometres 433 torr, and so on. The edge of space is considered to be around 100 kilometres up. The pressure there is 1.5 torr. Because there's very little air pressure up there, there's no force pushing the atmosphere into space. Having said all of that, we do actually lose atmosphere to space, but that's got nothing to do with vacuums and everything to do with solar activity and the magnetosphere.
What is gravity?
A force. That's about all you'll understand, Mark.
And remember that there are gases that already defy it, like helium, hydrogen, and fluorocarbons. Isn't it more logical to suggest that the atmosphere is being contained in an enclosed, pressurized system? They had no answer.
Okay, they still didn't have an answer for this. Right. And no, an enclosed, pressurized system is not more logical because you have to explain who built that system. Then we move into some very dodgy territory.
Number 3, eclipse shadow. Mainstream science tells us that the moon is over 2,000 miles wide, and yet during the 2017 American eclipse, no offense, the moon's shadow was only 70 miles wide, a reduction of over 97%. This is what the equivalent of having a 6-foot man walking in front of a wall where his shadow is smaller than an action figure at only 2 inches.
Hang on, let me get this straight. You're comparing celestial mechanics, movements of planetary bodies and the interaction with stars across vast distances unimaginable to the human mind to a man walking in front of a wall. That sort of comparison isn't going to cut it, buddy.
Where do we see this in our everyday lives? We've seen a shadow's actual size and some much larger. Where can we see small shadows? The Flat Earth community says that the moon is less than 50 miles wide, much closer and the same size as the sun. Isn't this explanation also possible? They had no answer.
Would they show this video to a porcupine in a lab coat or something? No, that explanation would not be possible. We can prove how far away the moon is. There's at least 2 observations you can do yourself to find this. For Pete's sake, the Greeks did it thousands of years ago.
Number 4, moon temperature. Science has yet to address this relatively new discovery that the moon generates a cold light. We all know that in the daytime it is 90 degrees in the sunlight, 80 degrees in the shade, depending on the conditions. I know I'm not going to do the Celsius conversion up here, sorry. However, at night, especially when the moon is high in the sky, we see the opposite. While it might be 50 degrees in the moonlight, it's warmer at 60 degrees in the moon's shade, sometimes showing temperature shifts of over 13 degrees Fahrenheit. In addition, under controlled experiment conditions, magnified moonlight is even colder still, again, the opposite of sunlight. We can generate this with technology today using a cold laser. The question is, why is the moon giving off a cold laser light? They had no answer.
I mean, come on. This one is easy. Radiative cooling is a process that occurs when the Earth radiates heat back into space. During the night, when an object is in shade, the heat is blocked a little bit from escaping. Therefore, the air is slightly warmer. When it's not in shade, i.e. direct moonlight, there's nothing to stop the heat radiating away. Therefore, the surrounding air is cooler. That's not difficult to look up at all.
Last but not least, the Van Allen belts. A simple yes or no question. Are the Van Allen radiation belts deadly?
Yes, they can be.
If yes, then how did Apollo 11 through 17 make round trips through these belts with only aluminum and plastic as shielding? No one died, no one got radiation poisoning, nobody even got cancer.
Our survey said...
Oh, wrong. Jack Swigert of Apollo 13 died of bone cancer in 1982, and Alan Shepard of Apollo 14 died of leukemia in 1998. Fake fact right there.
I think there's still like 5 left. Radiation is only stopped by 2 metals, lead and gold.
Our survey said...
Oh, is that it again? Some radiation can actually be stopped by paper, some by thin sheets of aluminium. In fact, only gamma radiation needs a metal like lead to stop it.
Both are very heavy and cannot be used in aerospace because of their weight.
Okay, enough of this. The Van Allen belts did pose a problem to the Apollo program, and they knew it would be a risk. They just decided to risk it. The trajectory of Apollo largely avoided as much of the belts as possible. They attempted to go up above them where the radiation dose was at its lowest. They also spent very little time in them due to their speed on the way to the moon. The shielding of the module also protected the astronauts during the journey, but what they depended on mostly was luck. On average, the astronauts were exposed to around half a rad of radiation during their trip. That's about 5 millisieverts. To put that into context, over the course of a year, you're exposed to around 3 millisieverts of natural radiation. So it really wasn't that much, was it?
The scientist viewed my recording and folded like a card table. This piece was never aired.
Well, that's a monumental waste of time for all involved, isn't it? I find it highly unlikely that a true physicist would not have answered any of these questions.
All that being said, my name is Mark Kendall Sargent, and I'm a flat earther. Flat Earth is my passion, it is my obsession, and it is now my life. I watched my very first Flat Earth video in the summer of 2014. Like many of you, I quietly laughed at it, and then I made a huge mistake.
You tried to eat a cheeseburger with your feet? You changed a light bulb whilst it was still on? You saw a wasp nest on your windowsill and thought, I'm going to keep this wasp as a pet. And you thought it would be a good idea to pick it up and give it a good petting?
I casually thought I could debunk it.
Oh, yeah. You kind of need some actual knowledge about the natural world if you're going to do that. No wonder you folded like a deck of cards. Mark Sargent epitomises the flat earth community. He has zero background in natural sciences. The man used to play computer games professionally, for Pete's sake. Yet he has the gall to elevate himself above men and women that have studied scientific concepts for the majority of their adult lives. And he stands there on a stage waffling on about complete nonsense whilst the onlooking flat earthers sit there dribbling all over themselves in the hope that they'll get a chance afterwards to just be in his very presence. What a time to be alive. Right, that about wraps it up for today. I hope that you've stuck with me to the end. Thank you all for watching. Please do like and subscribe to see more of the same. I shall be moving to the second weekly video from October, and the second release day will be a Tuesday. More to follow on that. Thanks again for watching. See you later. Have a great weekend.